Okay, we're going to go ahead and get started now. Welcome, everyone. Hi, I'm Iklak Sidhu. I'm the Chief Scientist and Faculty Director for the Sitarja Center for Entrepreneurship and Technology here at UC Berkeley. We're hosting today's event. Our mission is here at the Sitarja Center is to empower innovators to positively change the world. We do this through educating students in basically using the Berkeley method of entrepreneurship. And this is to develop their professional skills and their entrepreneurship and innovation mindsets and behavior. We also have certificate programs or professional programs, programs for professionals. I think one of our flagship or leading examples of that is the Engineering Leadership Professional Program, ELPP. This has been running for about 10 years now. And really, we have students that come from, really all of the leading innovative companies around the world, and particularly in Silicon Valley, Google, Apple, Samsung, Cisco, so forth. That program is a certificate program in engineering leadership from UC Berkeley's College of Engineering. We also have, just to give people an update of what is in the center, besides today's event. We also have technical labs and projects that happen in those, and those include things in data, AI, blockchain, deplastify, and lab areas in alternative meats, basically emerging areas. We're engaging with a lot of stakeholders around the world, both companies and universities around the world. And with all of that, it brings us to this activity. This activity is the Innovation X Roundtable. And one reason that we do it is that we've really seen a lot of change happen recently. I mean, in this last year, probably more than we've seen in our lifetimes, all at one time. And some of this change creates opportunity. It definitely changes the way industries work. It changes the way people behave. It changes all kinds of things that are meaningful in our lives. So we're looking forward to today's discussion on circular economy and how that's affecting supply chain and sustainable supply chain. But in addition to understanding what's happening in the industry, we also look at this as an advisory board, kind of a impromptu advisory board meeting in a way. So the participants, we're looking for you to help translate all these changes into what that means for Berkeley, what it means for our students, what it means for new programs in our center. So with that, I'm really looking forward to all of the discussion that happens. And I'm just going to start by thanking our panelists and handing it over to our moderator, Matthew Agues.
Thank you so much, Iklak. I'm not sure if you can see me. I can't actually, I'm not able to start my video. Okay, there it goes. Thank you so much. So yeah, thank you so much, Iklak, for this great introduction. I'm really, really honored and extremely happy to be with you today to moderate that panel. The way I see my mission basically is to be as silent as possible, leaving the stage to our wonderful panelists and just throwing questions at them. But before I start this, let me just introduce myself briefly. I'm the CEO of Schoolab. We call ourselves an innovation studio based here in San Francisco, but also in France and in Asia. What we do is we connect students, startups, and large corporations to create meaningful, long-lasting innovations. Our expertise is essentially around training, projects, and what I call collective intelligence, which I personally believe is what's going to save humanity in the future. But I'm also the director and instructor of the Deplastify the Planet class here at SCET. And I'm really thrilled to see that among the attendants today, we have some of our partners and students. What we do at Deplastify the Planet is bringing together students across campus with large organizations in order to find ways to design more sustainable solutions meant to be implemented in the real world. So I kind of feel home today being surrounded by students, academics, startuppers, investors, and some of our partners. And before I introduce our dear panelists, I'd like maybe to just highlight again the topic of the discussion today, circular economy. I believe that most of you are already familiar with the concept. That's probably the reason why you're joining today. But let's try to summarize it in just one sentence. I would say that circular economy is a closed loop model where the end of life of a product becomes the starting point of a new product. Basically fighting the widespread linear model of extracting, transforming, consuming, and wasting. What I'd love to achieve today with our panelists and with you, the audience, is first to understand a bit what is circular economy through the lens of those four experts. Also listing together the main hurdles and solutions to reach a perfectly circular society. And last, try to put this concept in a broader perspective and see how it does contribute to the major changes we have in front of us. Let's get started. And for each panelist, I'll ask you to introduce yourself and also ask you to answer a simple question that is illustrating the connection you have with circular economy. So if you guys ready, let's get started with you, Jeannie. You are the co-founder of Novoloop, a startup upgrading common plastic waste into a high-performance material. Would you mind introducing yourself and also telling us, in your opinion, what is the main difference between circular economy and simply recycling?
Hi, thank you for that introduction. Yes, happy to answer the question. Hi, everyone. I'm the co-founder and COO of Novoloop. And maybe I'll just answer the question and then segue into a little bit more on the company. So recycling today is often referring to turning materials back into the same materials or something of a lower quality due to technological constraints, and that's called downcycling. But recycling doesn't have to mean lower performance and quality. In fact, you can make something even higher quality than the starting material. And that's what upcycling is. That's what we do at Novoloop. Novo means as good as new, and loop signifies our focus on the plastic circular economy. So we are upcycling packaging waste like trash bags, a little demo here, and food wraps, shipment packaging into high performance materials for long-term use. So think shoes, car interior, sporting goods, building insulation, and more. So this is a new type of circular economy. It's no longer just about remelting plastics or even breaking down into the same starting monomers. We can actually chemically rearrange carbon atoms into different molecular structures to make better materials. Novoloop's vision is to be the most transformational materials company by showing the world what can be done with plastic waste. I'm happy to go into more detail later if questions come up.
Thank you so much, Jeannie. And yeah, we'll have a chance to speak again about like design, material, and so on. Let's move maybe to Douglas now. Douglas, you're calling from UC Santa Barbara, where you lead the Benioff Benioff Ocean Initiative. While telling us more about this program, can you help us understand how circular economy can somehow save the planet, including obviously the ocean?
Thank you, Matthew. Great to be on the panel. Wonderful expertise and good company on the panel. So I run the Benioff Ocean Initiative. I'm a professor at UC Santa Barbara. The Benioff Ocean Initiative is a center based at UCSB, which is about trying to leverage the power of research, try to design new technologies to create replicable solutions to ocean health. Now, our failure to engineer circularity specifically into this domain of plastics is creating a major challenge, one might say a new cancer for oceans. So that the single-use character, the throwaway culture that really is the dominant paradigm now when it comes to plastics around our planet means that when we throw things away, we have to have a trash can. And that trash can, unfortunately, right now is our oceans. So in the course of just the time that will be here in conversation today in our panel, about 1,000 tons of plastic will travel from rivers alone down into our oceans. And once it gets into the oceans, there are a host of insidious impacts that come to oceans, and in fact, come to us. So first, for oceans, for all the amazing species that you know and recognize that are part of our portfolio of life in the oceans, from sea turtles to whales to albatross beyond are impacted by many of them by plastic pollution. About 800 species of wildlife species in the sea have been documented to be negatively impacted by plastics. Now, as I mentioned, we're part of these systems because our human systems, our human business systems, our human culture systems, our human health systems link into the environment in inextricable ways, including to the health of our oceans. So that means that when we throw things into this ocean trash can, it throws things back into our own lives. We have plastic pollution, which is regrettably found in tap water, in sea salt, in beer, in seafood, the seafood we're putting on plates and from our families and our kids, into human placentas. The depth of plastic pollution's penetration back when we haven't achieved circularity in these systems into our own systems is truly extensive. So I suppose to try to succinctly answer your question, yes, yes, yes. A failure to address circularity in plastic systems means that there are direct impacts for planet, and indeed also for people.
Thank you very much, Doug. And the cancer metaphor that you use is a great segue to move on to Martin. I'm a big fan of Martin. You are actually a guest lecturer in the Deplastify the Planet program, but you're also a former chemist, and you founded the Safer Made, which is a fund dedicated to investment in new and safer materials. Martin, can you tell us your story and also how our circular economy can actually fit, your investment thesis and make our lives safer?
Excellent. Thank you. It's a pleasure to be here with everyone today. I'm glad to see the diverse range of voices and think about the ways that if we're going to transform the material economy, which is what we're really talking about here, changing the material flows through our economy. It's essential that we think about, as Douglas pointed out, the impacts that chemicals and materials have on human health and the environment. We believe at Safer Made that one of the drivers of change, not the only driver of change, but one of the drivers of change are people's desire for safer products. Think about it. When you go to the store, do you look at ingredient labels? When you buy clothing or other goods, do you look for certifications? If you do, what are you looking for? You're likely looking for brands and products that align with your values, likely things that you want to bring into your home, share with your family, because you feel like they're good for you and good for the environment. That has shifted store shelves, created new billion-dollar industries like organic food, the clean beauty movement. All of these things are different incarnations of the pressure that society puts on the material system. I think the circular economy certainly has been gaining traction both in the building world and in the apparel world lately. And I hope it continues to gain momentum. What we always focus on is, as we change the materials economy, how do we ensure that those new chemicals and materials are safe for human health and the environment? So I think that regardless of the name we put on the future of materials, whether it's circular economy or sustainability or green chemistry or biomimicry, I don't care what the name is. Let's just make sure I feel good giving it to my 5-year-old daughter.
Thank you very much, Marty. Let's move on to our last panelist, John. So John, you're a veteran from Genentech. You're now leading the BioCell lab for Bayer. As a biotech expert, can you help us understand the role of technology in circular economy, while also obviously giving us a hint on what's the BioCell lab?
Sure. Thank you, Mathieu. I would be remiss if I didn't start by giving a little shout out to UC Berkeley. I'm a graduate of this school, so go Bears. Good on you for all of those that are current and former students of the school. And thanks for that introduction. I am the head of the Cell Culture Technology Center at Bayer. It's a brand new facility. It's a therapeutic protein facility, still under construction, but we're very near completion. And when we're done, we will be producing therapeutic proteins, as I mentioned, that will improve, if not help, to save patients' lives. So it's something I've done my whole life, and it's super rewarding. It is a cutting-edge facility. It's got all of the newer technologies associated with production of therapeutic proteins. And in large part, that means leveraging single-use technologies. We commissioned and gained results, independently reviewed, peer reviewed, by the way, that really demonstrate that single-use technologies are, generally speaking, better for the environment. I'll say that loosely, but we've demonstrated that we will be using 50% less energy, as well as less than 50% of the water associated with a similar all stainless steel facility throughout its life cycle. But we do rely on plastics. So the vessels now no longer are made of stainless steel, they're a plastic bag. And everybody on this call pretty much knows that the recyclability of plastics, or the repurposing them, is difficult. Huge percentages unfortunately wind up in landfill, and we heard earlier, oftentimes in our oceans, and that's not good. So what to do? Finding ways to repurpose. I can tell you that I and other colleagues at Bayer, as well as other colleagues in industry, are working and partnering with companies that have novel approaches to repurposing plastics. We're working, and hopefully we'll enter into contract with a company that will turn some of our non-recyclable plastics into building materials. I think Jenny mentioned that opportunity earlier. One of the things I want to make sure that I stress to the folks on this call is that the way I like to think about circular economy is certainly larger and globally in nature and outside of my boundary at Bayer. But I also think it's super important to think about it internally. I am part of, I will call it an internal economy, even on the Bayer Berkeley campus, but certainly within Bayer as an entity. And here's a really concrete example. Some of the molecules, I am in a position to be a part of the manufacture of clinical materials, ultimately commercial materials. And some of those molecules require storage at ultra low temperatures, -70 degrees C. I think everybody knows about that now because of some of the vaccines that are out there. Nonetheless, the energy demands of a molecule that require storage at -70 are significantly higher than another protein, for example, that might require storage at -30 degrees C. Well, what if I insist that those molecules coming into my plant need to be stored at -30? I can work with partners in the development organization. And yes, that might require creation of new technologies and understandings and thinking a little bit differently. And I'm going to come back to that a little bit later about how we do our work every day. But I think those opportunities exist. So, the phrase "think locally, act globally." The think locally thing is something I really want to make sure that people hear in the message that I have to share today. And hopefully we'll get a chance to talk about how we can extend some of these concepts to external partners as well.
Thank you so much, John. So I hope the audience really appreciate the diversity of the profiles, the passion, and the expertise that we have around this table. So what I would love to do is really, put this knowledge and this expertise into action. As I think we kind of all understood that, circular economy models can definitely drive a lot of benefits for our lives. Now the question we could ask is, what are we waiting for? Why is it not already there? So what are the major roadblocks ahead of us, and what are some solutions to overcome them? So what we're going to do for this second part is look at the different angles, from a financial angle, a design and material angle, a supply chain and operation angle, a data angle, and maybe a political angle. And we'll try to point out, the different solutions and the different things that we can do, and how much circular economy can really be a model for the future. So for each point, I'll point out to one of you in the panel, but of course, feel free to step in anytime if you have something to add. Ginny, I'd like to start with you and with the financial aspect. In your opinion, what are the main things we should have to understand in the financial equation of circular economy?
Yeah, definitely. That's a very important topic. And I think there are two aspects relating to financials, perhaps two sides of the same coin even. So on the one hand, technologies and businesses that are coming out have to have a profitable business model so that they don't have to rely on subsidies. Their products and services need to be attractive to other industry players and the end users. And this is how you can attract funding in the early stages. So at Novolube, that's what we're aiming to do. We want to, eventually at commercial production scale, reach price parity with virgin performance materials. And that, incentivizes investors to come in at the early stage to help the innovation grow. In the next few years, if a tax on virgin is passed into laws, then, certain innovative materials may become even more price competitive compared to virgin. So in that case, there's no reason for anyone in the market to not switch to this more sustainable and potentially better and potentially even cheaper material. So on the other hand, that's really hard to do. New technologies and innovations that involve physical materials and manufacturing require a lot of time and capital. The current plastics manufacturing infrastructures were not built overnight. They have been depreciating over decades. So it takes long-term capital and government policy support to update our current ways. I think echoing what John said, this consumer mindset is really, really important. In the beginning of these innovations coming out, emerging, consumers have to be willing to pay a little bit of a premium to allow certain innovations to kind of take off, to get funding and scale. And I think a good example of that is what Tesla did at the beginning is one of the reasons why there are so many Teslas on the street now, and it's much more affordable. They came out as a premium product and targeted certain consumers that are willing to pay that and help it scale. So I think those kind of two sides of the same coin are related to why there are a lot of financial hurdles. Companies really have to prioritize, structuring their technologies and business models in ways to be profitable in the future, but consumers have to be embracing these innovations in the earlier stages to allow that growth to take off.
Excellent. John, I see you're opening your mic. Do you want to add something on that?
Nothing to add on that.
Okay, just checking. Let me move to Marty. Marty, so we just spoke about finance. You're an investor, so I think what Jeannie just said probably can echo a lot to it. But if you either want to add something on the financial standpoint, or otherwise, maybe as you're a former chemist, can you tell us more about the design and the material challenges that goes with circular economy, and maybe also bouncing on what Jeannie said earlier about the capacity that we have today to upgrade a product that used to be a waste. So I'd love to hear your thoughts on maybe those both points.
Absolutely, and I couldn't agree more with Jeannie's approach there. Both sides of the coin are going to be essential, and also we'll have to think about what financial instruments are needed to support a transition of materials, which may be different than the financial instruments we've have at our disposal today. But first, I will talk as a chemist, and I have bad news as a chemist, and that's that no one wants to talk about chemistry. It makes me sad every day. No one wants to talk about chemistry. Everyone wants materials, and everyone wants products that work, but they don't think about chemistry. So the first and most important thing to think about when it comes to design is function. So if you're going to try to break into this world of molecules and materials, no one cares, to be very blunt, if you have the same molecule that a company's been producing for the last 100 years, but it's slightly better. Maybe it has 50% less carbon footprint. Maybe it's made in a better place. Like, that is a really tough sell to get to the premium side that Jeannie talked about. It's hard for people to pay a premium when the function that the chemistry providing is actually the same. That said, there are reasons that people will pay a premium. And I see three real drivers that get over this complicated and costly barrier to scaling new materials. And that's basically differentiation on function, differentiation because of regulation demand. Basically, like Jeannie said, if you make something old cost more, all of a sudden your new material looks better. And the three is a perception of significant improvement in final performance. So you have consumer demand differentiation, you have regulatory bans, things like certifications and regulations, and you have significant performance improvements. All of those are levers you can pull as a new new company to help get materials to market faster. And that is critically important, because when you look at the time scale, as Jeannie said, of how long it takes existing chemical companies to underwrite a world scale plant, they're planning on a 20-year payoff period. It's part of the reason why incumbents are so resistant to change the chemicals they're making today. And it's part of the reason we do need innovators in the space creating the next generation of molecules, whether they're made from biology, like some of the work that John's supporting, or made from garbage, like the work at Novaloop, right? We need all of these solutions, and we need to find ways to support them from the early stage all the way through growth. And that's going to take, let's just be honest, hundreds of millions of dollars to make a scale that is relevant.
Wow, let me maybe just pause here for a second, because you brought the idea of regulation, of ban, of certification, and Jeannie, a bit earlier, you say if there is a tax on virgin plastic, that's going to change something. Any thoughts on how political leaders and policies can actually really drive this change and put us on the right track?
Matthew, if I can interject one thought there on that point, which is that I think there may be some need for revisioning this concept that you shared, Marty, of do we need, with policy and regulation, to make old materials cost more? I don't think of it necessarily that way, and I don't think that's the way you meant to present it, but really the way I think of it is actually doing proper accounting for some of the hidden costs that are associated with lack of circularity in some of these industrial systems and material systems. So what levers like that, policy levers that perhaps might attach new taxes to, say, production of virgin material for plastics are doing, would be simply trying to capture the economic externalities, the environmental externalities that plastic has as a burden on our environment, on our social systems. I mean, including that properly in these systems. Of course, our economic systems are bad at capturing these externalities, but we're getting better and better at both recognizing them at science and research and quantifying them, figuring out ways to use policy to actually do some of that accounting. And I do want to put in, I think there's a lot more to be said on specifics of policy, and we could certainly go there. But I do want to put in a point of observation, which is that I mentioned largely environmental costs, some of these hidden costs that are not accounted for and could be accounted for with policy. But there's a whole suite of social costs as well. So in our current paradigm, the system of really focusing on virgin for production of plastic, creates so many burdens and has a direct line back to issues in environmental justice and racial justice. So, and these are well studied in the domain of plastics and plastic pollution. So consider it the front end of this entire throwaway system. So when you have oil and gas or petrochemical that's producing both the raw building blocks and then producing feedstock for plastic pollution, many of those production facilities are disproportionately placed in communities of color and low-income communities, and pollution externalities that come out of that production are putting extra burden on communities that can't afford that extra burden. On the back end of this whole system of plastic, you have what we do with the plastic after it moves through our system, and that can be minutes of use, 5 minutes of use for a product that may have a 500-year lifespan. So what we do on the back end of the system, which creates more intersections, unfortunately, with these issues of environmental justice and racial justice and social justice, what happens after we think we've created a solution, we take plastic and put it in the recycling bin, right? We think we've solved the problem, but unfortunately, as been pointed out here, we maybe actually, and in many instances, are creating a problem, but a problem for somebody else, because that plastic pollution becomes exported often from wealthy countries to less wealthy countries, where some fraction of that plastic, because many of these less wealthy contexts have more leaky waste management systems, some of that plastic pollution ends up back in their lives and their environment. So this solution we thought we created at the recycling bin is a problem
figure out also what could be the consequences of circular economy models on supply chain and operation in.
Yep, thank you. A few things on that point. One of the things to think about is how long will it take to make this change? Is it overnight or is it over time? It's both. I really believe that. It's been talked about a little bit or alluded to, and I want to hammer it home. To me, this concept of a circular economy, and I'll call it sustainability, it's a mindset. If you think about a large capital project or any project, we've evolved as a society where it's systemic. People will think about the health and safety aspects of the project, and you simply wouldn't accept something that wasn't safe. You wouldn't be involved in a project that wasn't safe. How many of us do that around sustainability? I asked that rhetorically, but I bet the number is remarkably low. And that's not okay. So we have an opportunity there. The other thing I wanted to share, and I'll come back to this mindset concept probably over and over because I love it. Companies have targets. They have sustainability targets. Every company these days, Bayer is no different, has a CO2 emissions reduction target. At Bayer, it's to be carbon neutral by 2030. So it's pretty aggressive. Traditionally, people in my position or companies like Bayer and the Berkeley campus first question would be for me to reach out to Drew, who is our head of facilities and engineering, and say, Drew, how are we generating our energy, and what are you going to do to solve this problem? It's not Drew's problem. It's our problem. Yeah, Drew can help out by coming up with solutions on making things more efficient, perhaps changing energy sources. But I'll come back to this idea of thinking locally. I mentioned it a little bit earlier. And every single function within the company has the opportunity. And I'll use one important and relatively, hopefully illustrative example around food service. The Bayer Berkeley campus has more than 1,000 people every day that need to eat. They all want to eat. They want good food. How are we sourcing those things? What if the folks that run that service, that manage that service, decided that, as a matter of policy, we're going to source all of our produce from 100 miles and in, or whatever our commodities are. Do I really need water from overseas? Probably not. Does it need to be in a plastic bottle? You kind of see where I'm going with this. And you can extend that mindset to other parts of the business as well. If you think about a procurement organization, I'll go again. A lot of the things that we use, the commodities that any company uses, pens, pencils, paper, etc., where's that coming from? And understanding what it takes. And that was one of the aha moments of this life cycle assessment that I mentioned a little bit earlier. There's value there to understand this complete life cycle of everything that comes into your business, into your process, and colleagues on this call have already alluded to that. So creating a systemic approach to this and acting locally, everybody owns it. It's not one person. And I did want to share one other thing that was kind of inspired by comments that I think Marty and Doug made. It reminds me actually that if you want to be competitive, if you want to hire the best, having a very robust and public, a well-known sustainability program is a huge differentiator. The social consciousness around this has never been higher. We talked about recycling. When I was a kid, recycling wasn't a thing. I'm aging myself a little bit, but that's okay. And now, I wouldn't even think about it. You wouldn't think twice. And it's important. And the social consciousness around all of the things that we are talking about, it's real. And if I am, and it is my intention to create really some best-in-class programs and concepts around sustainability and employ them at the Bayer Berkeley campus, I think it's a differentiator, and people would be more inclined, if they have a choice, to work for an employer that's thinking that way.
Excellent. Thank you so much, John. Really appreciate the mindset aspect that you just brought. Before we move to the next section, one last question, probably for you, Doug. As we're at the SCT and as it's also one of the major is data, I'd love to get your point about, what's the deal with data when it comes to circular economy, and any takeaways we can get from that idea.
Sure. Well, we may be a special audience here, which is to say that there's excitement and enthusiasm about geeking out about data. Often, Marty, chemistry, conversation about data in a general audience might have the same amount of traction, but here I think we realize what is a founding principle for the way that the Benioff Ocean Initiative operates, which is that data equals power. If you want to change the world, we could talk about circularity or other domains. Data is your roadmap for how to do that effectively and rapidly. So let me just give you a specific example, Matthew, about data and pathways potentially getting effective strategy for circularity as it relates to the plastics question. So one of the programs, a sort of personal example, is one of the programs that we operate is called the Clean Currents Coalition. It's a partnership with the Coca-Cola Foundation that powers 9 community-led teams in 9 different countries all over the world to try to create new technologies to capture plastic pollution in rivers before it gets down to the oceans. Remember, science has highlighted that rivers are a really important pathway for the flow of plastics through our systems out into environmental systems and into oceans, and 1,000 again metric tons of plastic headed, unfortunately, to oceans as we speak this hour. So in this case, not only are they using this tech to actually capture this plastic pollution and intercept in an acute way this problem, but more importantly, the thing that gets us really excited about the Clean Currents Coalition in this intervention is the data. They're turning this plastic pollution actually into data. And in fact, they're using or engineering some new AI-based systems to try to actually quantify and translate all of that plastic trash directly into what will become, across this aggregated data set from all 9 countries, all 9 teams, the world's largest database on plastic pollution in rivers, an open database. And the value and the power of data in this particular example is that in that database, when it becomes assembled, are the answers that we may need, at least for part of this intervention. It'll tell us which products, which industries, which companies do we need to have these conversations first with in order to triage this transition from a throwaway culture to a more circular culture. So it provides that roadmap and that strategy for us. And I think we're actually deficient in a lot of different domains of circularity, from plastics and beyond, or other places we're talking about circularity, to actually have that data resource, that intel to actually figure out where we need to fight our first battle. So I think there's a great deal of power in data, and that's where we put a lot of our time and effort.
Yeah, I'd love to jump in on the data comment a little bit, because I do see it as essential, and in fact, often find that within supply chains, making data more transparent drives change on its own in the absence of regulatory pressure. Even to John's point, there are many organizations that are trying to do the right thing, but actually lack data from their supply chain. If you think about the brands we talk about as consumers, they often don't manufacture themselves. They have supply chains that go through multiple tiers of material providers and manufacturers. And the incentives there, which again get back to issues of environmental justice and social justice, are we've offshored a lot of that production. And that data doesn't even get back up through to the products that we buy. It drives me crazy that I can track an Amazon package almost down to the minute, but whatever's delivered in that package, if it's not a cosmetic or food item, has 0 ingredient information on it. It doesn't tell me where the materials came from, where they're ended up, how to dispose of it. It doesn't tell me if they're safe or harmful. And it kind of brings us back to like, what is the role of intervention in the system from a government standpoint? And I really believe that the first and kind of level of intervention should be around data, should be requiring more transparency for our products, what the provenance of them is, where they're going to end up, what they're actually made of, what material components go into them, because this is the sort of thing that levels the playing field. It brings a greater degree of competition to the system by bringing the data into it. And chemistry has been far behind CO2 and water accounting for years. So I'm really glad you're doing the plastics project, because at least that's bringing some of the chemistry accounting into it. And I would really encourage it to break it down to the level of resin code. Or is this polyethylene? Is this polypropylene? Is it PVC? It matters a lot. And so I think the first role and intervention of government should be around information and data. I think picking winners and losers, to your point earlier, of taxing and other incentives, they're very powerful and they can drive change very quickly, but they can also lead to what we call regrettable substitutions. If you pick winners and losers up front without having sufficient information, you may unintendedly be choosing something that has an impact somewhere else in the system. Kind of like John mentioned, his LCA showed that at least for water and energy, single use was more had less impact than a stainless steel, right? That kind of data can drive decisions. So I'll just leave it there. That's what I would love to see governments, both national and international, state-wise, do rather than trying to pick winners and losers.
I'll just jump in really quickly on the topic of data as well. And I saw one of the questions that came up was, where should we put our investments? Should it be on innovation? Should it be on existing technologies for collection? Is it policy? There is a pretty comprehensive study done by the Pew Research Institute that is focused on, how do we prevent ocean plastics, or how do we prevent plastics from becoming pollution? And it actually talks about, different solutions are suitable for different geographies. There are, really wealthy, developed countries, the investment dollars should be put towards innovations and other things. Whereas for third world countries where the, infrastructure is very lacking and there's no, material recovery facility or sorting plants, then you should put it into those kinds of infrastructure to at least have a base level of collection and sorting and identifying materials. So I think data is incredibly important, and how we use data to make decisions for what kind of solution is suitable in different geographies or different other aspects is going to be critical as we embark on this, solving this very complicated problem.
Thank you so much to the three of you to tackling this data question. And also thank you for monitoring some of the questions that are on the chat. Thank you to the audience for sending those questions to us. One that probably has been answered somehow was about how blockchain could be applied and what kind of usage could be done in the plastic ecosystem, let's say. I think based on what we've heard, we have a good idea, a good sense of how it could be used. And I'm just seizing this opportunity to promote one of the projects we've done in the Deplastify the Planet class 2 years ago with the Lonely Whale Foundation, applying exactly that, the blockchain framework to create traceability for plastic at the end of life, especially in third world country, not only to track and see where the plastic is going, but also to make sure the recycling facilities are accountable for what they have to do, and also to start a new model of spreading and sharing the value of plastic across the chain, including the waste pickers. There is about 15 million people making a life of picking waste in third world country. So there is definitely a lot of opportunities there in terms of data and blockchain. Another question we just had, and I love this one, it's a question we already had with Marty, and I think all of you guys will have some great insights, is how do we do the math with the trade-off? Because I think you've started introducing the fact that it's almost impossible to do perfectly on every side. What's kind of your guideline? What's your grid in order to manage those trade-offs between economical and financial challenge, between CO2 impact, between waste and so on?
I'll say something really quick up front. And this is, it's sometimes hard for engineers and scientists to hear, but that these are value judgments. Data is one piece. So data is the prerequisite to make an informed value judgment, but choosing water over CO2, over, a kilogram of lead over, those are value judgments. That's exactly what we have to face as leaders and decision makers, is that at the end of the day, we have to be able to decide what the values of ourselves as consumers are, but also of organizations and governments are, and where to put our limited resources. So I think that trade-offs should never be ignored. They are a real piece of trying to make change as we adopt new materials. And let's not pretend this is the limit of data. Data can give us the information, but ethics and values actually have to make the decision at the end of the day.
Matteo, if I could jump in on that one for a second. I also get the sense sometimes that people, individuals, companies feel that it's important to come up with a home run ball every time. I disagree with that out of hand, and would suggest that incremental improvement can be incredibly powerful, and it's certainly much more sustainable, because it doesn't take necessarily a lot of investment, time and energy to make small improvements over and over and over again. And you know, using the Bear case, we rented the engineering firm that helped us to create this baseline. So it helped us to understand, to know where to go, where should we start looking, and you know, where can we start to chip away at this. I hope that some of the really bright people on this call come up with some of these home run balls, and that we're able to implement them. But we don't have the opportunity to wait around for that either. We've got to start acting now.
Matthew, just a quick thought, which is just that to note that this is fast-moving space in the research sector, of how actually to get quantitative data on that you'd need for doing some of these trade-offs. So even in single tracks, trying to actually get quantitative data on some of these costs we're discussing, for environmental, for social impacts of plastics and the lack of circularity in that particular track, it's very early days in that space. Industrial ecologists have sort of just begun in a really good way, and I'd say the last 3 or so years, to be able to get quantitative data on the flows of plastic that are moving out of our current waste systems into the environment, into social systems, and some sense of the impact and the burden that has. There's a lot of work yet to actually put good numbers, and of course, as we mentioned, good numbers in different contexts, because those burdens vary. I think once we have some of those single track accounting measures more robustly developed, I think the natural thing will be to integrate those. And integrative accounting is what we do in all of our domains, thinking about, as John's building his building, what are the trade-offs, as there sometimes are, between water and energy and food waste, et cetera. So I don't think there's any conflict in actually trying to bring those measures together. I just did want to note that I think ocean scientists, industrial ecologists are moving very rapidly, and I'm grateful to them for doing so, and their disciplines, to try to get us this single track accounting quantitative data that we can then pull into more holistic analyses. But noting that unfortunately some of those numbers are not there yet, so we're perhaps not ready to capture those costs in their full form just yet. But important space, and a place for more research investment and more research action, for sure, because those accounting exercises are going to be super important.
Thank you so much. And one question I would have, because we're also speaking about the longer term and so on, is, in your opinion, do you see circular economy as, you know, something of itself, or just a transition? And I think we've spoke about the mindset, we've spoke about, you know, some kind of different thing on the longer term. Do you see it as a step in a bigger change, or do you see it, you know, as a transition? And what's kind of your take on the longer term?
I'll jump in here and talk about my thinkings here. So in a perfect world, we would only extract once and keep the resources in place, whether they're from petroleum, biological, or other sources. So fully circular model is one that we should strive for, but there are inherent scientific challenges. It takes a certain amount of energy to convert one type of mass into another. So not all the methods of conversion into circular materials make sense. So that's why circular solutions can and should look different when targeting different materials, rather than forcing one solution onto everything. You know, for example, trying to make the same thing over and over again. Maybe that works really well with metals, maybe it works with paper, but maybe not for all the different types of plastics that we have. So we need to innovate to come up with more suitable and custom ways to circularize the diverse resources we have. So in short, in my opinion, it is something that we should strive for, but we're just, it's not a very simple direction. There are so many different ways to enable circularity, and that's what we should stay open-minded to allow innovation to come about in this space to create this type of overall circularity.
Anyone else wants to jump on this one?
I don't know if this is the right time, but I wonder if I could add the perspective of what all of this means back to Berkeley into the conversation. We're heading towards the end of the hour in terms of the panel session. First, like before I take kind of like some comments on that, I do want to say that I've been taking notes through the whole thing. And I just want to appreciate like some of the like highlight things, at least that I got out of, starting with the trash, our trash can has become our ocean, the need for the profitable business models, the story of Tesla, the fact that people don't want just the same chemical done in a different way, the ideas of analyzing the entire life cycle of everything that goes in and out of your organization, the data aspect of it, and how that can tell you where to fight your first battles. All of those things, and of course more, have been just really insightful points. One thing, I'll take a guess of what I think it means for Berkeley. I think you had some comments about, well, the technology really matters. So, what can you do on the technical side? I heard business models basically matter. So there might be some intersections there. I'm also hearing the idea of value judgments and ethics, and that might take you to kind of utilitarianism or like some idea of like, for policy, what really helps the most number of people without hurting others, or, like concepts of decisions that affect policy there. But I want to like, maybe if everyone's got 30 seconds or a minute, what does it mean for our students? What does it mean for our center? What does it mean for the university? How do we best contribute to this change that's going on in the world?
Yeah, I will hop in real quick first. I used to run the Berkeley Center for Green Chemistry, so I was in similar shoes. And one thing that I learned was that students are the greatest resource that Berkeley has, and providing students the opportunity to interact with diverse groups, not just businesses, but regulators and NGOs. I can tell you that I think the biggest impact we had over the time I was there is where our students ended up going to work, and the fact that they are now leaders in their organization across the thing. So I focus on the students, and some of the things that I would say are important, and it sounds like you're already providing, are one, interactions with external folks. Two, how to make decisions in high uncertainty. I think this is the world that we're talking about. As we go to more and more data, which is key, we will also have to recognize the uncertainty in that data, and how do we make decisions in the face of uncertainty. So I'll leave it with there and turn it over to my fellow panelists.
If I could pile on to what Marty just put out there, for sure, finding ways to get real life experience for the students and for the academics as well. And maybe a little bit of a twist on something you put out there, Marty, understanding why it is that these companies, these leaders in these companies are making the decisions. What are the pressures that they are under? If you understand the why, then your solution has a fighting chance. If you just come from left field and you say, I think you should do this, you could get dismissed out of hand. So that's what I'll add.
Quick thought, which is to say, when we think about circularity in any system, but particularly when you think about circularity in the plastic domain, I think it's an incredibly complex problem. I think we're just scraping the surface here in our conversation, but the complexity of the issue for me means that we need to solve this with a shotgun, kill the beast with a shotgun instead of a silver bullet, right? There are so many different points of interface to try to address this issue of circularity, specifically within plastics. But happily, within the Berkeley ecosystem, there are so many experts that work in these different pressure points for where we need action on circularity. I'm a Berkeley alum too. Go Bears, adding that in the I think of my time there and my awareness that that there's expertise in policy. We mentioned some key opportunities, some live opportunities within the state, within the US, interesting conversations going on internationally about a Paris Agreement for plastic pollution and circularity there. So some real policy opportunities in the labs across Berkeley, and that can be in labs that are innovating around new materials that are cost-effective alternatives to plastic that can enhance circularity. That can be labs closer to the kind of organizations that are cranking out species like Genie that are thinking about circularity on the back end and engineering circularity into material systems. For leadership training and for people that will become, as many will, future CEOs, we need to think more about how these values become part of your operating principles for the way you run an organization, that future Johns, right, that are thinking not only about, as they must, neutrality for currencies like carbon, but neutrality for currencies like plastic pollution and circularity in those systems. And then lastly, communities in Berkeley that have a rich and deep history of experience and expertise working with communities on issues like environmental justice, where there's points of connectedness there, taking that conversation, listening to that conversation, empowering those communities to get involved in creating change is another important node in this holistic system of creating change towards a new paradigm of circularity. I think Berkeley is so well positioned to actually be a leader for action as it relates to circularity and plastic specifically.
Excellent. Okay, I think that, all right, I'm making sure no one else has a comment, but
sorry, I just, I wanted to jump in really quickly.
Yeah, absolutely.
Final thoughts over here. This is echoing something Marty said earlier, is that the fundamentals of chemistry and material science is so important. And without knowing what plastics are and how they're made, it's really hard to come up with bold and feasible ideas. So I think for Berkeley, you know, people who want to become part of solving the circular economy problem, we're going to this circular economy direction, should at least have a fundamental understanding, even if they're not chemistry majors. Maybe this is one very specific suggestion. I'm a big fan of science fair projects. This is actually where the idea for our company first came from. Give students the opportunity and access to resources to develop their innovations and for them to be evaluated on scientific novelty and commercial potential, especially younger students, undergrad students who have not become specialized in anything. They actually see problems and solutions with a much more open mind. And I think that those opportunities should be more commonly accessible.
Okay, fantastic. And I think that supports the power of the students' message right from the beginning as well. But I got it. Everybody, you know, everyone knowing some chemistry is part of that answer too. All right, so let me just say, this has been a great conversation. For me, it's like going to a class. I don't get to go to as many as you might think. And just getting a window into all of these different things and how they connect with each other. I just want to appreciate everyone's time. And I also want to say, get this point across, that there's the time we're spending right now in this conversation, but this video, it's being recorded, and these concepts are not lost, or they don't end here in this conversation. One of the things that we tend to do is use the roundtable videos with the student audiences as they are picking projects, as they are thinking about the things that they can do. So you're bringing an understanding to a set of skills, and together that redirects or changes the types of projects that these students will end up choosing to do. So thank you for bringing that perspective here today. And thank you, Matthew, for organizing and running the roundtable. The whole thing has been fantastic.